Thank you. Can you hear me okay? Yeah. That's good. As you can probably hear, I still have a croaky voice from a cold I had a month ago, so hopefully it'll last. Right, so we're going to talk about, I have a clicker. We're going to talk about how to build a data warehouse in an agile way. So if you haven't got a data warehouse, you've probably got several operational systems. One of the data warehouse people who started the whole thing, a guy called Ralph Kimball, described the operational database as a twinkling database, because most of the data just sits there, and every now and again someone does something and adds a new record or changes an existing one, signs up a new customer or something, and you get a little twinkle when it changes. So that's how operational systems work. They're just changing slightly all the time. Most organizations I've worked in anyway have multiple operational systems. It might be one for customers, it might be one for products, it might be one for HR, there'll be an accounting system. I've done data warehouses where they've had over 20 systems to be describing what their organization does. So what that's trying to represent is, if you look at the red triangles, you might be able to see they're slightly different colors. So several of those systems would have a record that relates to the customer in them, and each one would describe the customer differently. They might put the address all in one long field, they might specify the name differently, they might have initials and surname or first names as well in titles. So they'll all be slightly different, and they'll keep stuff that's specific to that customer and that system. When you want to report across the whole organization, you want one view of the customer. A single version of the truth is a common kind of ideal that we want to get to. This is what the customer is. So that's what we try and do in the data warehouse, is bring all that data together and standardize it and deduplicate it and correct it. And that big red triangle represents the sum of all those. So that's basically what a data warehouse is. The operational systems are application-specific data. What we want for the data warehouse is to have organization-specific data, application neutral, fancy words for that stuff. So traditionally, a data warehouse was used for reporting, consolidating data, as we just seen there, and also not slowing down the operational system. There were certainly times when, I go back a long way. I started work in this field in 1973 when I graduated. Then systems were very slow and couldn't support multiple loads. And one of the big things was you weren't allowed to run queries on the operational database because you'd slow it down. So that was when data warehouses were born, and that was part of the motivation then. What I've found more recently is that they're used for reporting and analysis and so on, but also for collecting the data together, getting that single version of the truth to either build a new system based on that one database, or more often to put in some package solution. COTS, as they're called. I hate acronyms, but anyway. Other words that you'll hear data warehouse people talk about is temporal database. And all that means is that it keeps some sort of history of something, like the changing addresses of a customer. It will keep the old one as well, have a start and end date for it, and put in the new one. But most operational systems do that as well, so I think that's a bit of a fake distinction. And then people still often assume that a data warehouse will be aggregated data to make it smaller, of course, that was in the old days, so that you had a smaller database and you'd maybe have monthly summaries of each customer's activity, if they were doing something very frequent, or monthly summaries across all customers. That's not what anybody wants anymore, because you want all the data and you want to be able to drill down to it in different ways. You don't want someone to have assumed the way you want to cut the data in advance. So what a data warehouse means now, what it usually means, what I think it usually, the users really want it to contain is all the data in detail. And you might use it for reporting, research, analysis, because the vendors will say insights, like you get some magical stuff out of it. But, yeah. And often for migration to new systems. And I think it should be as simple as possible, no simpler of course, but as simple as possible, very reliable, and with very good performance. You don't always get those things. So data warehouse projects tend to be big, because whatever the size of your organization, the data warehouse will cover all your systems. So it'll be the biggest system you have, or the biggest database anyway. And the big vendors have antennae, and they can spot a data warehouse project 50 miles away, probably anywhere in the country, and they want to sell you stuff. Because if you've got big systems, you're going to spend big money, and they can sell you data modeling tools, common data models, which I will talk about more in a minute. I'll talk about all of these more in a minute. Data profiling tools, data wrangling tools, things they used to call ETL tools and tend now to call data integration tools. And quite often, they're data warehousing methodology. I think you should avoid those big vendors. They will waste a lot of your money. And that's their job. You know, you go to Microsoft or IBM or Oracle or Informatica, their job is to get money out of your organization. I've sat in those sales meetings, I know what it's like. They say, why are you only getting $1 million out of them? They can afford more than that. That's how they think. And you need to know that they are not your friends. However nice the salesman is, however many drinks he buys you, he's not your friend. And their solutions are invariably, I'll boldly say that, invariably more expensive, more complex, and less efficient. So what I want to talk about today is how to avoid them. And what I've found, I've heard it, and I found it to be true in the projects I've worked in, is that you should trust your own developers, trust your own team. I think that's part of the kind of agile philosophy, is that we are, you know, there's not some emperor of data warehousing that knows everything, and the team are just little ants that are supposed to do what they want, what they're told to. Those people in the team know what they're doing. They've got skills. They've got stuff to contribute. So trust your own developers and recruit if you need to fill the gaps. If you do need to get an implementation partner, because this is a much bigger thing than you normally do, and you'll go back to a smaller thing, choose probably some of the companies that are represented here, which are small, motivated to do more than just make a lot of money. Obviously, you know, if you run a company, you want to make enough money to keep it going and to be secure that you can keep it going through good and bad times, but you don't have to become a multi-billion-dollar company. And usually when that happens, very bad things happen, in my opinion. So implementation partners that are small and that have good reputation. And if you can't understand the implementation partner's proposal, send them away. Because the key thing you want them to be able to do is communication. And some of the stuff that comes out of the big vendors is just waffle. All kinds of jargon and unfulfillable promises. So, and those big companies will do a traditional approach, where what you do is you get in armies of strategy consultants, data modelers, enterprise architects, working for years to design the ultimate solution. I hope to leave time for questions, but I do tend to think of examples that I really want to share with you. So I worked in one organization where they spent literally hundreds of millions of pounds designing their data warehouse. They had a whole team, it must have been at least 15 people, with massive workstations, with data modeling software that cost £6,000 a seat. And they had an A0 printer with a roll of paper. So it's A0 wide and as long as you like. And they had a data model that filled up a whole wall. And then when the developers came along, I said, we can't use this. Of course they couldn't, it was rubbish. But then if they do get to the end of that phase, they'll bring in armies of specialists in your chosen data integration tool. And I've often found it's cases of people who know a specific version, they've certified in a specific version of that tool, and they don't want you to change it because they'll have to recertify again. Again, they're expensive because not many people know about those. So don't do any of that. Right, this is how I think an agile approach works well for a data warehouse. And when I say I think it, I've done it, so I know it's true. And you start off by talking to the users and find out what they use most. I'm working in a charity, volunteering in a charity at the moment, and what they use most is the contact with, what they call supporter contact, which is contact with supporters and potential supporters. And the occasional person who's phoning up and saying they don't think they should be doing that. But mostly they're talking to those people, and they want to, when someone calls up on the phone, they want to find out what we know about that person already. Are they already a donor? Have they taken part in any of the campaigning actions that we've done? Have they complained about anything? What letters have we sent them? What were their replies? And with the old system they have, which is very, very old, anyone remember VT100s? Yeah. This was a kind of terminal that I was very excited to get in 1978. And their old system runs on a VT100 emulator. So what they wanted was to be able to search for a person very quickly. And what they could search on was the supporter reference number. Well, if you have a direct debit to a charity, you don't know your supporter reference number, do you? I don't know mine. So that doesn't help. Or the surname. Well, my surname's Ballard. It's not particularly common. If I look for it on their database, I get 217 hits. So they've got to kind of find the right one in that list. So they wanted to be able to just simply search their supporters and get the basic data about them. So the next thing to do is find out where the data is. Well, we found out it's in about 4 tables in the old system. It's a bit of a weird structure. And so what we did was to copy those from the old Oracle database into our staging area in our database, just a straight copy of that data, and then profile it, which I'll come back to later on. We improved it. We structured it in a better way, and I'll define what a better way is later on. And then we did this really, really simple web application. It was helped by the fact we're using Postgres, and that has really good text searching capabilities. So we indexed every text field, every word in every text field. So anything you know about this person, you've got them on the phone, they tell you 3 things, you can just type those in and it'll find them. And it does it in under a second. So that didn't take long. We just copied 3 or 4 tables. We just did a bit of SQL to restructure it into nicer tables. And we wrote this really simple web app. And they love it. And they use it every day. So that's a great start. I don't know if any of you saw the online keynote speech from the year we didn't do this, 2020, Sander Hugendorn. And he said, basically, we have a point on the horizon. That's where we're going with this system. And now we start building little things that take us in that direction. So that's a metaphor that I think really fits this. So, we went looking for some users that we could help, that we could show that we could do something. Then we started thinking more about what does the organization need next? And, standard agile thing, what are the stories? How's the priority? What's the benefit of them? And then we started doing those one at a time. And, of course, the big data modeling people will say, oh, no, you've got to have the whole data model, cast in stone before you can do anything. Not true. If you do that, it'll be wrong. This big one I mentioned before that cost hundreds of millions of pounds, by the time they finished it, it was wrong. It took them years to do it, and loads of things had changed. The company had been taken over by another company. All kinds of things changed, so it was wrong. So in my experience, a model that grows incrementally will be better than one that's designed up front, so long as we're not afraid to change it. Because that's the other thing with big data modeling things. Once it's cast in stone, that's it. It's cast in stone, you can't change it now. The model has to change along with the thing it's modeling. So we refactor the model ruthlessly, and it's not as bad as you think. You know, a customer record isn't going to change that much. You might start, you know, if you've got an old system, you might want to add various social media handles to customers, if you know them, and they weren't there before. All kinds of things will change, and you need to be able to keep changing it, and actually it's not that difficult. So we started off with our little data model. I don't know if you remember the picture from the beginning. That's part of a triangle. We just got part of that triangle, and then we added more, and we added more, and we added more, and we added more. Actually, it's a lot more iterations than that. And then something new comes along, and of course, new things are always shiny, so we want to add that. But you can do it. It's not difficult. Okay, so that's the data model. Common data models. There's a wonderful paper that's 12 years old now by, I should start forgetting names. It will come back to me. She worked with Ralph Kimball and helped write his books. And she did a really good kind of 2-page, 3-page paper on why common data models don't work. But the big vendors keep trying to sell them. And they keep selling them successfully. They keep saying, oh, you don't have to worry about the data model and stuff. We've got one. You want to look at it when it's actually been implemented. It's got loads of wasted things in it and loads of extra things in it. And it's not structured the way you want. So you don't want those things. Understanding your organization's data is difficult. If you've got an organization of any size, you've got different departments, different people who look after different systems, and they have a huge amount of knowledge about how that system works and how their data works. And if you're doing a data warehouse, somehow you've got to kind of collect, not necessarily all of it, but enough of it to really understand how to put it into the warehouse. That bit's hard. When you understand it, or even just a part of it, then the data model is easy. And you can change it easily, so don't worry about getting it right first time. But if you have one of these common data models, then you go through that process and you understand what your real data is like, and then you've got to mash it into this thing that's incompatible with it. Common data model is a marketing myth which actually makes money. But there you go. On the other hand, you do need to understand how databases work, as David Heinemeier Hansson said in his straightforward way. If you're going to use a relational database, you should damn well know how it works. If you were an American and you've been through an American university and done a computer science course, you probably have been told to get a book by a Yale professor that costs a lot of money. It's got 1,344 pages in it. It even tells you how disks work. Who cares? Who cares how a disk works? And a lot of people have put off relational databases because it's so kind of arcane and made to seem very complex. So I wrote one which attempts to get the important things across in a straightforward way. And I found this other one, the SQL anti-patterns, which I use. I refer to that all the time. So mine goes through, this is what you do and why you should do it. What anti-patterns does is, this is what people often do, this is why that's a problem, this is how you work around it and get it and make it better. So I would recommend those. I have just a few copies of mine here if anyone wants a discounted conference price. I won't have to carry them home, that'd be good. But the key thing about those is they're written in plain English. They don't dumb it down. They're not for dummies books. But you can read that and you can understand it and you can hopefully do what it says. And I've certainly tested mine on quite a few people. And with their help, actually, why do you say it like that? With their help, it made it more readable. Anyway, back to the data warehouse. And This is how we do it. It's really simple. You have a source system. You may have 20 of them. You extract data from that and stick it into the staging database. We're using Postgres, but I've done it with Oracle, Microsoft SQL Server, Sybase SQL Server, Netezza, loads of them. If it's a SQL database, the same principles apply. So we just copy the data into the staging system, into the staging database. And then when we've got all the systems represented there, or as we build up to having all the systems represented there, we can do joins between them, comparisons between them. And so the SQL on the right-hand side is a bit more complicated because it's actually restructuring the data and cleaning it so that you get a data model that you can use in the warehouse. We run this every night on the charity I'm helping with now. 270 million records. We copy them, we restructure them, we clean them, we index all the text fields, and we do a whole load of reconciliation and data quality checking on that in 4 hours. So 6 o'clock in the morning is ready. Yesterday's midnight's data is there for the users to use the next day. There's an organization they're working with at the moment who reckons it will take 5 months to do what we do in 4 hours with a big vendor product. Anyway, you can do it in 4 hours, that's fine. Usually, this organization has got their biggest table is 80 million rows. I've worked with banks and telephone companies that have had over 1 billion records, sometimes tens of billions in their main table. So the principles are the same, but you have to, when you've got those kind of volumes of data, then you do have to think carefully about how you move the data across. But for this one at the charity, we did originally just copy all the tables every night. So we delete what we had yesterday, replace it. For the 3 big ones that are all about 80 million records, we've started doing incremental changes. It just gives us a bit more time to do testing and stuff. But it's a bit more work to do it. So the first step is just try copy and replace every time, because that's easy to write. So for very large tables, if it's got a timestamp on the record, like the last time it was changed or when it was inserted or when it was deleted, then you can use that to select out the ones that have changed in the time period that you're interested in. If you haven't got that and you can get into the back-end database and add a trigger, then you can have a trigger which records when each record changes. It's an automatic database thing. You just define it and it will make sure that you've got a record of all the ones that changed and when they changed. If you can't do that, then you can do some kind of difference calculation. Either way, you get it all into a flat file. I was really pleased that Emily was yesterday was giving the merits of flat files, plain text. If you do that, then you can do a difference on it, which at the operating system level is really efficient. If you're using Unix, a diff is about as fast as you can possibly do it. If you can't do that, you can do the same thing in the database. It's a bit more expensive, but you do what you have to do. Now, when we come to the creation of the warehouse structure from whatever idiosyncratic structure you had in the source system, then this is where the vendors will try and sell you an ETL tool. Now, this is you can't see it, but there's a lot of screens there. This is what you have to go through with SSIS to do what data warehouse people call slowly changing dimensions. Basically, that means I've got a record, I want to keep that, but when a new one comes along, I want to end date the old one and put in the new one with the new start date. Very simple thing to do. That's what it takes in SSIS. And those yellow boxes have actually got SQL in them. So you have to write SQL anyway. And it's really complicated, and it has workarounds in there because SSIS is so inefficient. This is the equivalent SQL. That's that same whole process done in 2 SQL statements. And even if you don't know SQL, it's not too difficult to work out what's going on. Number one is updating the customer history, set the valid to the end date to the current date. And it's a bit of checking to make sure it gets the right ones. And then you insert the new ones. That's all there is to it. Why would you buy a tool that does all that? I worked for one of those companies one time, and I ended up as the consultant who was going around and fixing the things that the tool couldn't do. And that's when I started to realize that those tools they may make money, but don't touch them. So we write everything in plain text, and has the many advantages. We write short, simple scripts, so that one on the right is populating one table from 3 others, one table in the warehouse from 3 in the source system. And this controlling script, it can be quite long, but it's dead simple because it's just a sequence. No loops, no branching, just do this, do this, do this, do this, do this, do this. And these little statements here, which you can't see, are just, in Postgres, it's \i, which says, include this script. And we don't use any views, we don't use any stored procedures. We have a couple of little functions written in the stored procedure language, but we don't do any kind of procedural stuff in the procedural language. And no monsters. This is just a small part of a monster. And it's truly horrible. I had to understand what it was doing, and it took me ages. 600 lines long. This is, I don't know how many that is, about 60 maybe. And yeah, it's got mistakes in it. It's got comments in it which this didn't seem to work, so I took it out. If you know Hunt and Thomas' book, A Pragmatic Programmer, they talk about programming by coincidence. This has got masses of evidence of that kind of, try this, it worked. Oh, well, it might work, I might want to keep it. Yeah. So we avoid those. This is a listing of our repository. It is sorted by size, so that's kind of cheating a bit, but the top one is 154 bytes, that's one script, the bottom one's 440. Some of them get a bit longer. Some bits are very repetitive in a warehouse build, where you've got to take these records from this table, add in these records from this table, add in these records from this table, and so on. And so there are a few that they might get up to 100 lines, but we haven't got any 600-line scripts. We try to keep them small, simple, and then when you want to change something, it's in the version control system. You can change it, you can test it, you can do a new release, and it's much easier. Those ETL tools, source code control means copy the whole thing, the whole lump, into the source code control. I worked on one place where it took 8 hours to do that. If you use source code control, well, this is Subversion, and most people use Git, but it's the same thing. You check something in, check something out, fractions of a second. Right, how am I doing for it? Okay. So there are useful tools that we use. This is data profiling. There are data profiling tools out there. First time I used one was at a telephone company. I thought, this is brilliant. I want this. I'll explain what it does in a minute. So next place I went to, they said, we're not spending £100,000. It wasn't. We're not spending £100,000 on that. You don't need that. So I wrote one. And I've used it ever since in many organizations, and you can have it if you want. It's not, I think every time I've installed it in probably about 10 different organizations, I've done the installation. So I think my installation description needs a bit of help. And if you do download it and you try to make it work and it doesn't, send me an email. You'll have my email address. I will happily help. Anyway, what data profiling does is the columns on the left, which you probably can't read, are stuff straight out of the database metadata. Column name, data type, length, and whether it's nullable or not. In other words, whether it's allowed to be empty, mandatory or optional. And then the rest is calculated from the data. So we have how many nulls are there in this column? And that one, so the total rows is 2.8 million. The top one, 2.7 million of them are null. So that's quite interesting. How many distinct values are there? what's the minimum, what's the maximum, what's the maximum actual length, and then we got frequencies and patterns that I'll come back to. If you're loading all the data from an old system, there'll be some rubbish in there. If someone can show me an old system that hasn't got rubbish in it, I'd be very interested to see it. So often, this won't find all the data quality issues, but often the bad data sorts to the end of the bell curve. And here's a couple of examples. This is real. So this is a date of birth that's in there. And this is first name, second name. First name is / / backtick. And surname is ZZ Tope. Well, I know there's another one just below, which is ZZ Top. Anyone remember ZZ Top? Yeah, okay. They were coming to fame when I went to university. They're still going 50 years later. It's amazing. And I'm still going so far, so that's all right. Then frequencies are, that's not on this slide. It's very simple. It's just what are the most common values, what are the least common values. Again, in the least common values, you quite often find data quality issues. This is patterns. And on the right, again, it's probably a bit small for you to see, but it just replaces each character in the string of the original value with a capital A if it's an alphabetic character, a 9 if it's a numeric character, an S if it's a normal space, and at the bottom is B if it's a non-breaking space, where someone's copied something in from a web page, and then you search for it and you can't find it because a non-breaking space doesn't match a normal space. Punctuation marks, currency symbols, accented characters, math symbols, and control characters. And up here we've got something that is just 6 control characters. I think, if I remember this one rightly, it's 6 new lines. What does that mean in a text field? Just 6 new lines. What's it there for? And then one down here has got load of leading spaces. We've got more control characters there. We've got some punctuation marks. And again, this doesn't tell you absolutely that the data's wrong, but it points out interesting things to go and look at and say, is that a candidate for us to clean? Does it tell us something that we should be looking for some other kind of patterns that may be misleading? So that's patterns. Another thing we do, and this is the testing that we talked about when briefly, and I went to work at a telephone company some years ago now, and my boss was introduced to me, and I found out he was 3 months younger than my daughter. And he was brilliant. I really loved working with him. And he was looking at all these kind of reports that we get in the data quality team. And he said, it just takes so long for these. What I really want is something like this. And he described it. And I built it. And I've used it and kind of improved it a little bit ever since. So after the data warehouse is loaded, and in most places it's overnight. I mean, it might always be that. It might have to be at a weekend or something. But usually it's overnight. So after that run's finished, we run a whole bunch of tests on the data that's been loaded. And we color code them, of course. And then for each group, and also for overall, the color is the worst in that group. So you can see the red one. There's one bad one and 17 good ones. The next one's got three good ones and 20 bad ones. So that's red. We need to go and look at that. And we can drill into those and see what's happened. It also produces charts of how values have changed over time. This is quite a recent one. So the charity collects most of its donations via direct debits, and those spikes are the direct debit runs every month. And there's some kind of glitches in the pattern. So especially those two close together, So we go and have a look at those and what happened? What happened there? You can't have just done the whole direct debit run twice in space of 3 or 4 days or something. So what happened? It turns out one of them had been reversed. if there's one missing, then we know the direct debit run's failed, or our collection of that data has failed. Something's gone wrong before it got to the data warehouse. So these kind of charts just give you a kind of quick view of what's happened. It gets a bit more complicated than that, but I haven't really got time to go into that here. And if you want to drill down and see what the actual numbers behind the chart were, it will do that. If you decide there's an error and you want to create a ticket, you click on a button and it takes you to our ticketing system. And you can just create the ticket there and then and refer to the chart. And that's what that does. So, Small Sharp Tools. Anyone come across that book? Well, it's called Small Sharp Software Tools, the one in the bottom right. It's about the Unix command line. I love it. It's a really good book. So the words on the left are the things that I think you must have. The icons on the right are my current favorites, which you may think are a bit eccentric, but it doesn't really matter. So for the wiki, we use track. I really like it. I've used some of the commercial ones that I didn't like Confluence. Linux, actually that's non-negotiable. For me, I will not build a data warehouse on a Microsoft Windows server. That is just too much pain. So it's got to be Linux. Database, again, I prefer Postgres, A, because it's free, B, because it's rock solid, C, because it's hosted some of the biggest databases in the world. It used to be used for Skype. Of course, when Microsoft took it over, they switched to SQL Server, and I think Skype's a bit slower now. It also, there's a marine traffic database, which tells you where all the boats over a certain size are in the world, using a system called AIS, which is another acronym I don't remember how to translate. But it's a system that sends the information about where the boat is at any time, and it's very, very big, and that runs on Postgres too. So Postgres, I've used it for a long time, it's never let me down, and it's free. SQL Server I've used, perfectly good database. Oracle's a perfectly good database. Even DB2 is a good database. Well, Microsoft and IBM can't leave a good thing alone. They have to add all kinds of features which make it worse. But so that's DB2 and Microsoft SQL Server. And Oracle's another story. Well, the main problem with the Oracle database is that you get the Oracle marketing machine piling in on you, and you don't want that. So we've got a team of 4 people, plus me helping out. And we use Subversion for source code control. And that's very simple. It does what we like. Git, of course, was designed for massively distributed development. And that's where you get all the branching and stuff. And I'm happy to work with Git. We've done it before. But given a free hand for a project of this size, I would choose Subversion, and that's what we do. Plain text editor, that's the first one that I had to pay any money for. The others are all free. And I think I paid 50 quid for TextMate. Again, I like it because it's just a good text editor, but also it's got this wonderful feature that you can pipe your document that you're working on through a Unix command. So I can cut out columns 1 to 4 and columns 53 to 71. And it will take, it'll do what the cut command does in Unix. I don't know any other editors that can do that. And you'll need a procedural language for some bits and pieces. I mean, we've used it mostly for doing our web apps, and we've used Java, but there are loads of good languages out there. So the icons are, that's personal. The things on the left, the words on the left, I think are mandatory. And as I said before, you can download the stuff that I've developed and then had tweaked and improved by other people I've worked with over several years. And they're available, and you can get them from my website. And as I said, since I'm retired, I can afford to do this. How many people we got here? If you all send me emails at once, it might take a bit of a while. But generally, I'm very happy to help people with these because they're developers' tools. They're not nicely packaged things. There is quite a lot of description on the website. So those are available, and that's it. So we got some time for questions?
4 minutes, yes.
4 minutes, sorry, I didn't leave you very much time. But anyway, if you do want those, come and pick up a card. If you want a book, I'll be very happy. I won't have to carry them home. But, that's up to you. Right, questions? Yes, go.
Amazon Redshift, I've never used it myself. Have you used it?
It was quite trendy a little while ago. I don't know much about it. And I've not come across it recently. A lot of people have talked about Snowflake and said that's pretty good. I don't know. One thing I would say is that the things I don't trust are the things that are not based on relational databases. So I worked on a big project with a data lake, Hadoop system, and I think it comes from organizations that collect gossip in huge quantities, zettabytes of it, and use it to steal people's data and sell it to advertisers, like Google, for example. That's what data lake's used for, unstructured data. The systems that I work with are structured. A customer support system, it's about people, but it's got things like names and addresses and postcodes and dates and amounts of money. It's strongly typed data and strongly structured data as well. These transactions belong to this customer, not just somebody in some amorphous mass. So the relational databases are much better than those tools generally. But I'm sorry, I can't really answer about Redshift. Yes. Oh.
I love your approach. I just wanted to ask if you would make a recommendation on when this approach would work in terms of size of an organization or size of a project. Is it more fitted to, small organizations? Would it work for an enterprise? Where was it applicable?
It's quite widely applicable. So the one I'm working on at the moment, the charity with 80 million records in its biggest table, that's towards the low end. I worked on the payment card processor that processes half the card transactions in the country every day. And that's 30 million transactions a day, that's 1 billion a month, and they had 7 years worth of data when it worked there. I've worked for telephone companies which tend to have tens of millions of customers and therefore hundreds or possibly thousands of millions of transactions. And banks, I worked for the biggest bank in Turkey that had tens of millions of customers and had its credit card system and everything, and it worked there. So it's quite a wide range, really. Yeah. It wouldn't work for the big data things like Google that have got zettabytes of text because that's a completely different problem, I think. But yeah, if the organization's got some kind of structured data and different silos of that you want to bring together, then it's going to be suitable for that.
I think we're out of time.
Oh, sorry. Well, I'll be around for the rest of the day, so come and find me.
Okay, thank you.